So hi everyone. I'm so happy to be here, first time in person since 2019. Thank you to COVID. So yeah, today I'm going to talk about Kubeflow, and just want to ask first of all, how many of you heard about Kubeflow? Yeah, I think half of you, because we've seen a lot of really great presentations about this project. And today we just a little bit talk about how we try to improve it for our customers. So first of all, I think all of you seen this picture like thousands of times, right? But it's still present, right? Because the main problem is like we've seen a lot of talks during these 2 days that currently ML engineers, data scientists, they have to know about everything, right? They have to know about Kubernetes, they have to know about DevOps, they have to know about cloud, and specifically like ML code has very small amount of piece that if you want to promote the production. And more precisely, this story present right now, because I've spoken a lot with many people, and they tell me all the time that they have to wait around, I would say, half a year or even more to push this model to production. So it's a really problem that currently industry doesn't have a solution to make it possible to fastly build and push models to production and make money from it, right? So what basically was the goal of Kubeflow project back in 2017? The community wants to build portable, scalable, and simple solution for ML. And how basically they want to build it? They want to use it Kubernetes. Because eventually, folks from Google, they think that Kubernetes is the future, and it's the future for ML, and Kubernetes out of the box provides solution for all these kind of needs that we need for ML ops, right? And we don't need to build another abstractions to cover all the use cases for ML. And speak a little bit about Kubeflow. So many of you like ask me, what is Kubeflow? And basically, Kubeflow is a set of different components which can work independently and also as the whole platform. And Kubeflow contains different working groups and different components. For example, components for notebooks, components for training operators, for ML metadata, for serving, K-serve project, for AutoML, project Katib, and for the pipelines. And also, since we're running Kubernetes, it's very easy to deploy this on any public cloud, on-prem, or even on your local laptop using Minikube or Kind. And also, Kubeflow offers some sort of the interfaces for the customers, such as SDKs, web UIs, kubectl access. It's make it very easy to interact with this project using UI, when even you, like Kubernetes expert, you can use other tools. So I want to speak about two projects in the conference. So I want to speak about training Kubernetes first. And what is it? Basically, training Kubernetes is a controller to handle distributed training on top of Kubernetes. It supports mostly all of the frameworks you know, such as TensorFlow, PyTorch, XGBoost, MXNet, MPI. And in addition to that, it allows you to do additional stuff, such as elastic training, job scheduling, high-performance computing, and other stuff. Like, of course, you can implement this by yourself if you're a Kubernetes expert. But if you want to take this controller out of the box and just use it on your compute, you can just take it from Kubeflow. And speaking about like distributed training, it's actually hard to run distributed training on Kubernetes. Because in this picture, you can see already used techniques, how the distributed strategy works. And basically, our training operator is responsible to properly scheduling the workers, to properly share the weights between the workers, and make basically allow you to run distributed training on Kubernetes. So during like the demo, I will show you how easily it can run from your notebook. But the idea is the controller will handle all the scheduling, all of the allocated resources, and make possible this to run on top of Kubernetes. So this picture is how to all reduce looks like. Next step is I want to speak a little bit about Katib. So Katib is a project for AutoML, and it basically supports HyperParameter Tuning, neural network search, and early stopping right now. Also, we're looking forward to support other AutoML techniques, but it's quite new. Like feature engineering and model compression, it's super new field, and there are like not many algorithms that industry supports right now. And also, like Katib uses for the algorithms other open source frameworks such as HyperOpt, Optuna, scikit-learn, scikit-optimize, and again, it's natively integrated in Kubernetes. So, speaking a little bit about architecture of Katib. So the idea is very simple. If you know about HyperParameter Tuning, you know how it works. So basically, user just creates an experiment. We have a different experiment controller, which handles the CR. Then we have a suggestion controller, which is responsible to spawn the algorithm service for you. And the algorithm server just produces hyperparameters. Then the next step would be the trial controller, which spawns the trials, and each trial is a training job, which basically can be anything. And this is like the power of Kubernetes, because for us, we can do the abstractions, so we can schedule the Argo workflow, the job, or even the TF job for distributed training in terms of trial. So it's all of this natively supports in Katib. It can be run using Kubeflow. And then when the trial is finished, the metrics is collected using the metrics collector, and then we pass the results back to algorithm service to produce new hyperparameters. So the idea is quite the same for all the algorithms that you know, such as Bayesian optimization or random search. But basically, this is like how it's implemented inside Katib. So I want to speak a little bit about the gap. So I've been in community for, I would say, 4.5 years, and the biggest gap right now is documentation. And this is the slide for like the results from our recent survey. Many people are actually complaining that Kubeflow is hard. We don't know how to use it. Like the documentation is not really fit all of our needs. And for us as a community, we really want to push forward to decrease the complexity of Kubeflow, and especially like how to run this in Kubernetes. And that is why, like for example, this one, right? So this is the YAML files for TFJob and Katib experiment. It's very complicated. Data scientists, they don't need to worry about them, right? So they just want to run their models on Kubernetes easily. And moreover, they need to build the containers, which is very complicated for them. They need to know about Docker. They need to know how to create different, use different environments, right? And make sure that it's running on top of Kubernetes. So we want to avoid this completely. And how? We do really small steps, first of all. So we want to improve our SDK to make sure folks can run their training function just using our clients, right? So at the top, you can see the pure TensorFlow code without any Kubeflow SDKs. So you can see that you can define the multi-worker strategy. You can define how your model will be compiled. You can define how you started training. And then you can use the TFJob client. And then you can just define the function you will train. So it's super easy, super native to Python, right? Because this can be run from a notebook. You don't need to worry about YAMLs, Dockers, and other stuff. So you can have a unified experience from local to Kubernetes. And similar to Katib. So this is the example how our SDKs can be used without building the images. So they are the same. You define the objective function at the top. Then you just print the metrics and the hyperparameters you want to tune. So the first step will be just training that your objective function working, so the second style. And the next step, just spawn this hyperparameter tuning experiment using Katib. So you define a search space for A and B, and you define the tune function where you have your objective metric and the trial budget and the objective function you want to optimize. So very simple. Again, it's first initial step. We're looking forward to how we can improve it, and we're looking forward for the feedback from the users. Because pipelines also, like Kubeflow pipelines also follow the same approach. And here I want to quickly show you the quick demo. I hope it's going to run. How this can be run from the Kubeflow dashboard. So let me try to click this. Yeah, I think this should work. So yeah, this is Kubeflow dashboard. All of you should be familiar with that. And what we try to do, we will try to create a few examples from the notebook directly. And we're going to use one of the notebooks that I created before. So you can spawn notebooks in this central dashboard, super easy. So this is the notebook that we're going to use. In this notebook, we're going to use 3 different steps. So the first one is define a model using just a simple MNIST example. Then we're going to improve the hyperparameters using Katib. And then we're going to use multi-worker strategy using TFJob. So the first step will be just installing our SDKs, quite straightforward. The next step would be creating the training script. And if you're familiar with TensorFlow, this script should be very easy to understand. So basically, you have the parameters as the input. You have the TensorFlow package that you need to import. Then you have a learning rate, a number of apex as the input parameters. Then you can define the distributed strategy. So this is the pure TensorFlow native using all reduce that I shared before in the presentation. So the next step, just define the custom callback because Katib needs to actually collect the metrics in appropriate format. So we're going to collect accuracy and loss for Katib. Also, as you can see, we're just going to prepare our MNIST data set. So we just do some pre-processing here. Very easy, we're very straightforward using MNIST data from the open source. And then we just need to build a model. inside the one function. So simple CNN model, have a couple of layers, have like 10 digits as output. You just need to compile this model in this function. And then you just need to define the distributed strategy as you can see. So there are like, you can run this code in distributed fashion or just in sequential fashion if you just want to see that your code is actually working right. So the final step is just run model.feed, where you define your data sets, number of epochs, and the model that you want to tune, that you want to train. So the first step is just running this model locally, right? Just to see that code is working and everything is fine. And this is running inside a notebook, right? So you don't use other compute, just having in your kernel, the notebook kernel. So as we can see, the model is successfully running. We can see some of the epochs results here. And then we can do some iterations with the Kubeflow components. So the next step would be just using Katib for HyperParameter tuning. So again, it's super simple. As I mentioned, you define the parameters as a dictionary. You define the learning rate and number of epochs that we want to optimize. For learning rate, we define the search space. So Katib supports a couple of different search spaces, such as double, integer. We're also looking forward to support like log uniform, malicious distributions. So quite simple, define a minimal and maximum value for your hyperparameters, and then similar to what I showed before, define the tune function. So here you have the experiment name, you have the objective function, then you want to optimize. The objective function here is the train function, right? Because we're going to optimize the TensorFlow code. So then the hyperparameters, the algorithm, Katib supports a lot of your algorithms out of the box. You just need to set the name. Then the objective metric, main that they want to optimize, which is accuracy in our particular example, and the metrics that they want to collect, which is loss. And also the trial threshold, basically the maximum number of trials and how many trials you want to run in parallel. So since we're starting the experiment, we can jump to Katib UI, same in the central dashboard. We can see the experiment status here, how many trials are currently running. We can click to the particular experiments to see some results. Here on this page, we're going to see some information to the user, such as best trial till this time, best trial parameters, best trial performance, accuracy and loss, and some experiment conditions. Also, we're going to click to the trial page. So this is the page with all the trials that we run. We run, again, to remind, like 2 trials in parallel. So when a trial has succeeded, we're collecting the metrics. If we're going to click to the trial page, you're going to see that loss and accuracy have been collected. You can analyze your metrics just to see how they've been populated. Also, at the bottom, you can see some overview, such as minimum, maximum value for each metric, the latest results, and the trial conditions. Also, like right now, we also can click the details just to see some more information about the experiment, about the parameters, and other parts. So we try to avoid the YAML because, again, as I mentioned, not many people like to just analyze YAMLs. They want to have good interfaces on the UI just to see it. And right now, we need to wait until more trials will be finished and our HyperParameter tuning experiment is complete. So this UI will be automatically updated, and we're going to see more results on the plot. And also, the best trial will be highlighted at the table at the bottom. So also, we're looking how we can improve this UI. So, for example, print the logs for the trials, just removing completely the kubectl access for the data scientists, just to make it easier. So we can see the best trials have been succeeded, and we have the best hyperparameters on this UI. You can see some results, and the experiment also will be finished. So we can go back to our notebook. And if you don't want to use this UI, you can also use the Katib SDK to collect the optimal hyperparameters. You can, again, just use the notebooks without any UIs. We can collect the best learning rates and best number of epochs based on our, depends on our experiment. And then we can use this best hyperparameters in our TF job experiment. So again, the TF job, similar to Katib, you just define the input parameters from our distributed training, so from our HyperParameter experiment. Here you define the distributed strategy, the number of workers, which is 3 workers, and you define the create TF job from Func API. So you pass just your function, your training function, your parameters, and number of workers. And it's very easy to scale, because imagine you have 3 workers, but maybe you want to run this on 100 GPUs, right? So you can just simply say 100 replicas, and it will automatically scale, depends on your compute. So here we can use the TF job client to see some results from Kubernetes clusters, such as the pod names, the current TF job status, and the logs from our training. So you don't need to switch to your cluster. You can do everything in your notebook. And as we can see, the training is much faster and is much better because you can imagine you can start this training for a couple of weeks, a couple of days, without worrying about that your kernel is dead or your notebook is out of memory. So it's completely asynchronously from your notebook, which is running. So this is a quick demo that I really want to show how much time I have. Yeah, it's OK. So before I finish, I just want to say a couple of things about the community. So please try out these examples that I shared here. There are a couple of Katib examples really interesting that you can follow. Also, all this cool stuff won't be possible without our great community. We're always welcome to the new contributors, to everyone who can attend our free community meetings, which is happening every Wednesday for all model training. Also, there are all different community meetings for Kubeflow that you can join. Also have a Slack channels for the Kubeflow Slack. And if using Katib, please update the adopters list. We're looking forward to have interaction with our users and the customers of Katib. And also, if you want to learn about Katib, you can follow this link on the presentation side. And to contribute, you can check developers guide, submit a proposal, or even solve some issue with the help wanted label. Also, you can get in touch with me on Twitter or LinkedIn. I'm more than happy to introduce you to the community or to Kubeflow, just give you some ideas how you can use it. And just collaborate in the future. And also, at the end, I really want to share because the general already shared this, but finally, after I would say 4 years of debate, we tried to apply for CNC for incubating project. And I think it's a great step for the overall Kubeflow community to become a part of the huge CNCF umbrella. Hopefully, this will get accepted. And in the next KubeCon, we're going to give a talk about how we have a future for our roadmap and vision of overall umbrella of Kubeflow project. Yeah, I think that's it. Thank you so much for listening. I'm more than happy to answer questions.